Good afternoon. It's an honor to be here. I'm going to ask you today to think about the world in a way you've never been asked to think about it before. And the talk really is about my concern that you've never been asked, no one has ever been asked to think about the world in this way, and my indignation about that state of affairs. So this may be abhorrent, but by dissecting the four-word title, which is admittedly a little bit odd, we have the entire talk. And we will start with the word world. The world, well, here it is. We've got it. We're experts at it. We know what it is. How do we experience the world? How do we operate the world? If we roll back time and consider that we undo all of technology, undo all of progress, and we're the first little group of humans crawling out of something or other, some previous more slimy state of being, then the world is only the world. There is nothing constructed. It is what it is. And our experience of it is purely through our senses. So the world presents itself precisely in a literal sense. We understand it through a set of sensory apparatus that have been evolved to understand it, and that's that. Now, something has been added to the world. There is a new substance in the world, and I'm not going to use the word technology because I think that's a little bit inaccurate. It is computation. That's an uglier word. People don't like it. They also don't like the word computer, but that's what we're talking about. And I think all technology that has come before is not as influential and not as dramatic a change in the world as computation. And the strange thing about computation is that it is the opposite of the physical world that we were evolved to understand, in the sense that it has no built-in representation. It is purely 100% abstract. And therein lies the problem. How do we experience it? To get at that, I would like to use an analogy. It's a disposable analogy, but I'll stick with it for just a moment, and that is architecture. And I'm going to suggest that out of the many ways that our own ability to construct the world has enabled us to understand it, architecture is a pretty good tool, a pretty good interface for understanding and shaping space, for shaping geometry. And I'd like to, I've never done this in a talk before. After hundreds of talks, I'm going to read something from someone else. This is a quote from Christopher Alexander, the fantastic hybrid British-American architect. He says, "The purpose of all architecture, the purpose of its spatial geometric organization is to provide opportunities for life-giving situations. The central issue of architecture and its central purpose is to create those configurations and social situations which provide encouragement and support for life-giving comfort and profound satisfactions, sometimes excitement, so that one experiences life as worth living. When this purpose is forgotten or abandoned, then indeed there is no architecture to speak of." Okay, so what's important there? Two things. One is that we've got a domain, architecture, that's concerned with how we organize and understand and interact with space. The second thing is that here's one person at least who's interested in talking at the meta level, talking about what architecture is. And right away we can interrogate it. We can say, well, I don't know Maslow's pyramid. Architecture's all about making sure rain doesn't fall on your head. But that's not what he's talking about. He's not talking about the shack or the hut, although that is very interesting architecture. He's talking about what it means to design architecture. What is the meaning for us? What are the semantics? And therein lies the difference. So we get, of course, to the punchline. What is our interface to this purely abstract world of computation? It is, self-evidently, the user interface. But here is the problem. No one has ever asked you to think about, in a broad sense, the user interface before. There is no Christopher Alexander. There is no group of concerned scientists, concerned architects, concerned policy wonks. There is no one in this domain who's saying, how do we judge ourselves? What do we need to do? What is this stuff worth? What are the dangers? And so I think we need to start doing this. There are two ways to address the problem of even asking and answering the question, is UI any good, and what do we need to do to improve it? And I've spent the last 25 years doing one of those two things, which is to try to build examples that shows a step forward. The other thing, and this is the thing I'm trying today for the first time, is to ask people to talk about it. Critical dialogue is what we want. So to understand where we are with UI, it's interesting to understand where we came from, or at least important, if not interesting. It doesn't take very long, unfortunately, because here is the complete history of modern user interface. One, we go from scarcity to abundance. This has very little UI to speak of. You type in language, language comes out. Sometimes it's graphics, doesn't matter if it's an Apple II Plus or an Atari or a Sinclair ZX80 here in the UK. It doesn't matter, it's all the same experience. Suddenly, Everyone can have computation, and that changes everything. It's a kind of quantitative change that begets a qualitative change. But this is the huge moment. We go from abstract, language-based stuff, that's one part of the brain, to pictorial, iconographic, spatial representation of the interior state of the computer. And this is a thunderbolt. This makes it so that 100 times, 1,000 times as many people can use computation as used it before. And this is as good as it ever got. This is exactly what you're still using today every time you flap open your laptop. Two more things happened. This happened. The browser, the web came along and turned the internet into this, right? And so the proposition was, this is the one program you'll ever need ever again because everything is out there somewhere in the cloud, and you access it through this, and all UI will happen in this. And unfortunately, UI itself as a discipline and as a design field took a sort of 15-year step back, took a bigger step backwards than it had existed so far. Then the other thing that happens is this. You get to take computation with you. Fantastic. We wouldn't give it up for the world, but the UI is diminished. It is literally smaller in a physical sense, and what you can do with it is less. It is less capable. So that's all we've got. We'd like to go forward now. How will we do it? I'm going to propose that the most useful source, the abundant source of clues for figuring out how to go forward is the world. Everything we know about physical space and relationships in physical space and trajectories of understanding and relationships and causality and the rest of it that embodies the entire physical universe, and start building that in. So, not to be a complete downer, let's take a look at some examples of what could happen if we start to build the real world into our idea of what user interfaces could be. So let's take a series of 5 negatives, turn them into positives. In a typical user interface, you don't work in the real world. You work in a kind of miniaturized version of a not real world in which you project your consciousness, and it's a dull and very restrictive and regressive world. But let's say what would happen if we could work in the real world, and it might be something like this. What that means is you're working in the real world. The pixels come into the real world. So in the little tiny pin brain of the computer, there is a fluid flow simulation running. That's the abstract part. You could look at it on a screen, but this work says, no, let's put it in the world, and let's make it so that physical objects in the world can interrupt the simulated flow of fluid. That is completely different. Even though the maths are the same, the underlying simulation is the same, what's new is the human understanding that comes out of it because of the UI. Same idea, a little bit of a slightly more elaborate evocation. Here you've got buildings. You've got little architectural models. It served that discipline incredibly well for 3,000 years before we invented CAD. Shame on us, forcing architects to lock their physical models in the drawer and just stare into an ugly screen. But now bring the models back out, make the computer do the hard work of finding them in the physical space, and now you ask and answer questions about space, about geometry, by using space and geometry to test out a new configuration of a building, to see if it's going to reflect light onto a nearby freeway. You just move out your hand and you turn the building. This has the kind of innate causality that everyone understands from the time probably that their eyes get wired up and they can see and move their limbs. 9 months to a year and a half, let's call it that. So this works for everyone because it partakes of the user interface that we all know from the physical world. And even if the underlying simulation is as it would be without a UI or with a screen-based UI, what comes out and what goes into our brains is completely different. 2, you don't really use your hands. I mean, yes, you swipe some skin grease across your little phone, or worse still, you use a mouse. And when you use a mouse, you take the incredible dexterity evolved over, let's call it 5 to 50 million years, built into this, the human hand, unbelievable numbers of degrees of freedom. You clutch it around a piece of plastic, the mouse, and you move it around in the plane, and what comes out is not even very continuous. It's integer x and y. You might as well not have fingers. But if we said, no, have fingers, please, use your hand, use your hands at the full measure of dexterity that they were born with, if you're lucky enough to have working fingers and so forth, and what you get is a system that, again, feels like the real world. And the first thing that you build is pointing, because pointing is the most magical, it's certainly the most geometric of human gestures. Pointing is a gesture that's geometric. It connects your body to other distant objects and bits of space. But even better, it's not for you. You point for the benefit of other people. It's a social gesture, and people can do vector math in their heads. They know what you're pointing at. That's incredible. So if you teach the machine that, you've suddenly got action at a distance. Anything you can see, you can point at. Anything you can point at, you can control. And that works all the way from free space gesture down to touch, which is just a strange and constrained kind of gesture. You can reach out, you can grab data, you can pull objects, literal or figurative or abstract, toward you and inspect them the same way that you would in the real world. Sometimes the pixels move underneath the object. Sometimes the pixels are physical, and they should submit to the same control systems and the same gestural vocabulary that you have elsewhere. And on like that. After pointing, the next most important thing is navigation. And it turns out that with one hand, you can actually navigate through all 6 degrees of freedom that we have in 3-dimensional space, which means you can find your way through any space. And if you clamp together data visualization, which we've been good at for a long time, with this new idea of free navigation, you've got a kind of incredible new sort of understanding right at your fingertips. And it goes on like that, and you can continue to build more and more sophisticated applications around it. Now onto the machines. One of the very strange bits of awful legacy about the way we've been building computers, and this is one even though we don't call it that, there's 2 big ones, but one of them is that although this thing, of course, has a network and it's connected logically to the rest of the world, we still say that the user interface and the meaning of this device stops at its physical boundary. This machine, this computer, cannot really in any meaningful way connect to any other computer. But if we invert that and we say, every display surface is just part of a continuum, and we will make sure that the underlying computational infrastructure allows computation, allows display, and allows interaction to flow onto multiple surfaces, then you get this. Here's a little tiny piece of media running around 5 different screens in our laboratory. The 5 different screens are being driven by 3 different computers running 2 different operating systems, but they're all running the same program, and that's all it takes, at Oblong at least. And what you see is a single continuous interaction. It's hard for the computer, but it's exactly what the human being wants. The human being doesn't care that they're different operating systems. What you want is to use all the pixels in the same way to get your understanding done. The 4th thing, this is interesting. If you think about what your representation is inside the UI, the most advanced UI that we have right now, which is still that Macintosh UI, the overlapping windows, the scroll bars, the clicky buttons, the rest of that, where are you in all that? Well, you are the little cartoon arrow. That's a 2-dimensional cartoon of something that's physical in the real world, but it's worse than that, because actually the arrow just helps you find the real representation, which is a 0-dimensional point at some particular x and y, and that is you. Now, you can take offense or not. I think you should. That is all of you that there is represented inside the UI. If we're going to build more sophisticated systems in which there's not just one person, but a lot of people, you're going to need to do better than a mouse cursor. You're going to need to understand what someone else is thinking, ideally. You're going to need to have something that I think of as cognitive empathy. And in the simplest case, you ought to know what someone else is seeing. Where is their attention? If you're working together to try to solve a problem, you'll need to know where attention is. So this is a system, an experimental system also at our laboratory, in which we've got an incredibly thorough and high-fidelity scan of the Italian city of Florence, which is incredibly well scanned. And what happens is that you've got 3 different machines subscribing to an underlying database and simulation, including traffic and emergency response vehicles. But if you see that yellow quadrilateral on the big screen, a 40-foot wall of pixels, what it's showing is what the little screen is looking at. So that is a representation not just of the data, but of the person who's looking at the data. And now the next step is you can actually grab that representation of a view and move it around. It's like very gently and graciously grabbing someone's head and turning it so that they can look at what you want them to see. And it expands outward from there to involve more and more systems. And it's symmetric, right? In the future, there can't be any sort of master-slave, which is a horrible term that computation has adopted anyway. Can't be a sort of master-slave architecture. It has to be symmetric, bilaterally, trilaterally symmetric. Anyone can grab anyone else's stuff and move it around. That's where the design has to start, at least. And after that, you can build in security and so forth. So that is the idea of making it so that you can see what someone else is seeing. You can understand what someone else is understanding. And if you continue to build in that way, you have a UI that is about human cognition, not about the awful little brain of the computer. And I'll stop just for a moment here to say that these are examples and these are demonstrations. But if you take all of this, this is just by way of saying this is not purely hypothetical or experimental. If you take all of these concepts and put them together, we've built a system called Mezzanine that is actually a product in use on 6 continents around the world by 150 companies that is about collaborative computation. It combines all of these ideas. So this is actionable. That's important to understand. It's not hypothetical or theoretical. It is actionable. And the final piece is this. Machines can't do the most important thing that we do as individuals. As individuals, we are best as part of a larger structure, a larger society. And we get at that by exchanging ideas. We write books that each other reads. We speak to each other. We draw pictures. We act for each other. We do everything that we do, for the most part, so that other people understand us. But if we could get machines to do that, that would be interesting. So this is the most experimental piece of the lot. But in this scenario, computation itself, programs and data are all fluid and fungible. And what happens is that individuals with applications on, in this case, a laptop, approach a large shared pixel and computation workspace. When they get close enough, proximity is sensed, and the code itself jumps across the air gap and starts running on the big screens. And if you instrument the code itself correctly so that it can advertise a little bit about what inputs it takes, what outputs it produces, then the programs themselves, even without having been pre-arranged to do so, can start to interact. And that's depicted by the lines that are flowing back and forth between them. And the computation follows you around, of course, because where you go is where your program should be, and so forth. So this is a view of a future operating system that is about people. It's about the interoperability of human ideas and data and programs. And this is the kind of thing that we should be driving toward. So this is the other piece, the piece that I'm not personally working on, but I think the world needs to. We need critical dialogue around the user interface. User interface is all we have. And we've suffused the world with technology. Computation, sorry, I broke my own rule there. We've suffused the world with computation. It's too late. We made the decision by not making a decision. It's here, it's everywhere, it's in literally every room in your house, it's in your pocket. We should be concerned about the way we get to access it. We can build solutions to it, but we also need critical dialogue around it. And to do that, we need vocabulary. We need ways of speaking about what's good, what's bad, what's interesting, what's futuristic, what's desirable, what's abhorrent to do with user interface. And we need to start. And we need a few metrics along the way. One of them I've suggested already, which is capability. How able does a UI make you? How capable does a particular UI make not just you, yourself, but a group of people, a team? And then there's one other metric I'd like to suggest, which is exhilaration. The word excitement appeared in Christopher Alexander's mini manifesto, and it's true too. Even a user interface, if it's construed and built properly, can make you feel excited. It can give you the same sensation that you get when you scuba dive or ski or play improvisational jazz on a clarinet or do any of the other things that remind you that you're not just a mind and not just a body, but both combined together in real space with other people, with other minds. And that is what computers need to be. We have to put the world back into computation. It was born without a world of its own. It is our job to make sure that we remain in control of all that stuff, and the best way to do it is to make it participate in the real world. So with that, thank you.
So, John, one quick question. So tell us a little bit, because you have big companies working with Mezzanine. NASA, Boeing, if I'm not mistaken. When they start using Mezzanine, how did that change the way you actually understood your own product because of the way innovative ways they're using it? Was that the case?
Does the way we understand the product itself change? Absolutely. I mean, I think the one good test, there are two great tests of a new technology or a new product. One is if it supports comedy, and I don't have time today to explain how that works or why it is, but you just put children in a mezzanine room and you learn. The other is if people start using the product, using the technology in a way you didn't expect. And that's constantly the case. We learn from our customers all the time. But the thing they have in common is that they need to collaborate. It doesn't matter whether you're doing oil and gas exploration or policy drafting or any of the rest of the 10,000 things that human beings do. You have to work with each other. And watching the way that people work with each other and watching at this level instead of at this level is what makes all the difference.
Amazing. Before you go back to LA, do you mind coming to the Wired offices and installing the software?
It's on its way already.
All right.